Today we are going to design finite automata which has odd number of zeros and any number of ones. For finite automata we should know Q and sigma. Sigma, it is mentioned in the question, it is a binary number system. That means now we have to design the binary number. So we are going to design the binary number by using this formula sigma closure. And after getting all the strings we are going to collect them in one set, and after collecting them all in one set, what we have to do, after finding sigma, now we have to find q. Now for finding the q, now we have to sort out the string according to the requirement. We have to collect all the strings which are having odd number of zeros and any number of 1. So after collecting all these things, what is common in that the strings are having odd number of 0, but the string can start with 0, like 0 1 can also start with 1. That means the string, if it is starting with 0, we are going to consider as 100%. Starting with 0 and any number of 1, 100%. Starting with 1. Now, according to the question, if the string is starting with 1, it has to be rejected. But this contains 50% of the requirement. Here the portion of 0 is missing. Here 1 indicates the odd number of 1 and even number of 0. So the number of 1 also we have to consider. That's why it contains 50% of the solution. Now these are all the rejected string in which the number of zeros are even. Now how we are going to proceed? Based on the percentage of zeros, we are going to mark them into two different states, either the acceptable state or the rejectable state. Now Q0 we have to mark as the initial state which consists of no input, no output. So Q0 either can start with 0 or 1. Starting with 0, it is according to the question, it is odd number of zeros and no contains of 1 means even number of 1, and we are not going to bother about the number of 1. We are going to focus on the we are going to focus about the number of zeros. So odd number of zeros, 100% requirement, and that we are going to mark as Q1. Now number of 1 is single 1. That means the portion of 0 is missing. 0 missing means we are going to consider no occurrence of 0 as even number of zeros. That means it contains only the 50% of the required thing. That means Q2 we are going to consider as even number of 0. Now we are going to consider as Q1. What is Q1? Q1 is the state which indicate odd number of 0. So what do you mean by odd number of 0? Here the string. This string is represented by Q1. So that string we are marking as 0 and 0. Q1 represents 0, that is the odd number of 0. Now the next bit can be either 0, can be either 1. If we are going to add the second bit as 0, that means from the odd number of 0 we are making as even number of 0. For the even number of 0 we already have the state. Even number of 0 is indicated by Q2. So even number of 0 is also represent the 50% of the solution. So it represent the 50% of the solution. It is marked as Q2. So what Q2 represent now? According to this 0 0 is 50% of the required thing. Now the Q1, which already we had marked as odd number of zeros. Now if the next bit is 1, we'll make the number as 0 1. 0 1 is also the according to the requirement odd number of zeros and any number of 1. So it contains 100% of the solution. 100% of the solution is indicated by the state Q1. It contains odd number of zeros. Now what will be the next state? The next state will be Q2. What is Q2? Q2 represents the string starting with 1 containing 50% of the solution, in the sense that it contains even number of 0. So Q2 represents 1 and 1, single 1. The second bit can be either 0, it can be 1. If it is 0, now it is going to convert from even number of 0 to odd number of 0. So that's why it containing the 100% of the output, and the string containing the 100% of the result is indicated by the state Q1 as indicated above. So odd number of zeros it marked by Q1. Now Q2, if it is having the next bit as 1, it is even number of zeros. Even number of 0 we had marked already as Q2. That's why we are having resultant state of Q2. Now Q2 can be marked as 1. It can also be marked as 0 0. So what is, even though the strings are different, here the string is 1 but the condition is same. It contains the even number of zeros. That's why we have considered Q2 as 1 and 1, single 1 here, with the next bit as 0 or 1. It can also be marked at double zero. Double zero also indicate the even number of zero. So if you are having confusion, so why here we have taken 1 and why 0 0? Here the condition in both the case, in single 1 and double 0 is same, containing the even number of 0. So here we have considered Q2 as 1. If we are having confusion, why we have not taken 0 0? So same thing, even number of zeros. Again, if we have considered for your easy to understand, we have taken Q2 as 0 0 also. But the condition in both the case, the situation is same. Q2 in this case represent 1, in this case represent double 0. Condition is same, it is containing even number of 0. If you are going to append all single 1, it will convert to odd number of 0. Odd number of 0 means the state Q1. If we are going to append one more bit as 1 for making the next number, will be changing the condition from even to even only. That's why it containing Q2. Same in the above case. Even number of 0 after adding single 1 will convert to odd number of 0. Even number of 0 appending a single 1. Q2 is representing single 1. After appending one more 1 remains the same. That's why Q2. So here we can find out. So even though we are taking different string 1 or double 0, the state will be same. So what is Q2 in short is even number of zeros. Now the next step is to create the table. So what is Q0 is the input, is the initial state without any input. So Q0 with 0 is odd number of 0. Odd number of 0 we had already marked as Q1. Now Q0 with 1, Q0 nothing, with next bit as 1 we had marked as 50%. 50% is represented by Q2, that is the even number of zeros. Now Q1 we had already considered this thing as an odd number of 0, that's why we had marked it as a final state. So final state in your state table we had to put asterisk. So Q1 with the next bit as 0. So Q1 represents the odd bit. Odd zeros with the next bit will make it even 0. So even 0 we had already marked as Q2. Q1 which is odd 0 with the next bit as 1 will be remain as it is odd number of 0. That's why we have Q1. And next even number of 0, that is Q2 with the next bit as 0 will make it as a odd number of 0. That's why we are having Q1. Q2 with the next bit as 1 will remain as it is, that is a even number of 0. That's why we are having Q2. Now we have to complete the state transition diagram. So the initial state here is Q0. Now the Q0 with input 0 goes to Q1. Q0 with input 0 goes to Q1. Q0 with input 1 goes to Q2. Now Q1 which is the final state, from the table we came to know. So now what we have to do, we have to mark it as a final state by putting double circle. So Q1 is the final state. Q1 on 0 goes to Q2, on 1 goes to Q1 itself. Now Q2 on 0 goes to Q1 and on 1 will remain to itself. So this is how we had completed finite automaton for odd number of zeros and any number of ones.